Originally released in 1972 by Atari, Pong is one of the earliest arcade video games. It was initially intended to be a warm-up project for a new engineer, Alan Alcorn, to familiarize him with game development. He went on to create the prototype, connected it to a black and white TV, and the game was born. To recreate the game in Godot, first of all go into project settings, then into the display window size, and make sure that it's set to 1152 for the width and 648 for the height. I then create a Sprite 2D node, and this is going to be my background. I'll rename it to main, and then I need to load over my image into the texture property. I've got this background image here, so I drag it over into the texture. I then go into the offset and I untick centered to position it correctly. If I zoom in on this line, you can see the edges of it are actually a little bit blurry. I go into the texture down here and change the filter to nearest, and that sharpens up the image for me. I then create the player paddle. I'm going to create a static body 2D node and rename it to player. This node then needs a couple of child nodes. The first one is the color rect, and the second one is going to be a collision shape 2D node. And that gives me this little rectangle up here. I'm just going to change the size of it. So I go into the transform property and I set the width to 20 and the height to 120 pixels. It's currently being positioned from the top left, so to change that, I set the anchor preset to center left. To be able to detect collisions, I need to use this collision shape 2D node. I'll define a rectangular shape, and then I just need to adjust the size of it to match my paddle. It's easier to do this if you turn on this grid snapping option, or rather the smart snapping option, that just allows me to snap to the edges of the piece. Once done, I can position the whole paddle correctly. I go into the transform and change the position to 50 by 324. And now it's sitting nicely in the middle of the left-hand side of the screen. I then select these three nodes and go into duplicate. I'll rename this one to CPU, and this is going to be the AI controlled paddle. I'll need to make sure that it's repositioned, so I go into the transform property and change the X position to 1082. So now this paddle is on the opposite side from the player paddle. For the ball, I'm going to use a different node type. I create a child node of character body 2D. Similar to the paddles, this also needs a color rect node and it needs a collision shape 2D node. I'll rename this node to ball, and I can then go into the color rect node and update the size of it inside layout and transform. It's too big right now, so I'm going to set it to 10 by 10 pixels, and then I'm going to set the anchor preset to center. So now the ball is going to be positioned from its center point. This also needs a collision shape assigned, so I'm going to use another rectangle here and just resize it to match the shape of this ball. Now I want this ball to be positioned in the middle of the screen. So I go into the ball node, and inside of the transform property, I can set the X coordinate to 576, which is half of the screen width, and 324, which is half of the screen height. So the ball looks like it's disappeared, but it's actually just sitting there exactly inside of that middle divider line. Now I'm going to set up borders around of my game board. For this, I'll create another child node, which will be a static body 2D, same as the paddles. There's going to be two collision areas, one above and one below. So I need to create two collision shape 2D nodes as child elements of this node. I'll rename these nodes accordingly as borders, then as top, and the second one as bottom. And now, just the same as before, I'm going to create rectangle collision shapes for them. I'll turn on this grid snapping so that I can see a little bit easier what I'm doing, and I will just extend this to be the width of my game board and to just start right at the outer edge of it. Then I do the same with the bottom border, create a rectangle shape, drag it down here, and then make sure that it just starts at the limits of the board and maybe extends just one grid size. It doesn't really need to go too far, as long as it has enough space to detect the ball passing through. These top and bottom collision shapes will mean that the ball is able to bounce off of them. The left and right is going to be a little bit different. I don't want the ball to bounce off. I want the ball to go off the screen and then to score a point for the opposite player. These will be created slightly differently. I'll set up another child node of my main scene, and this will be an area 2D node. Inside of that, I need to add in a collision shape just like I did previously. I'll rename this one to score left. And then I can create a rectangular collision shape just like I did with the top and bottom borders. So I'll extend it down here, and it's going to be just on the left hand side of my game board. We need to do the same thing on the right hand side. So as an exercise, pause it here and try and do this yourself. For practice, you should try and set these up manually, but I'm just going to duplicate these nodes with Control D, and I'm going to change this one to score right. Then I just need to move the collision shape over from the left hand side over to the right hand side, like so. It can be a little pernickety, so I'm just going to make sure I've got it exactly right and none of the areas are overlapping or missing. Oh yeah, I've got a little bit missing here, so just to tidy all those edges up. Okay, so now all 4 of the borders are covered with some kind of collision shape. Since these borders are actually touching in the corners, we potentially will get some collision detection between the two. We only want collision between the ball and the borders, not the borders themselves. So to fix that, we can move them onto different layers. So if I go into my borders and I go into the collision set here, I can move them onto layer 2 instead of layer 1. Then I go into the ball, go into its collision properties, and make sure that under mask I'm selecting 1 and 2, so that it's colliding with everything that's on layers 1 and layers 2. That way it collides with everything that's on layer 1 and layer 2. Next I'm going to set up a heads-up display that's going to show the scores. So I can create a new node as a child, which is going to be a canvas layer node. I'll rename this canvas layer to heads-up display, and add a child node which is going to be a label, and I'll rename this one to player score. I'll set some initial text here as 0, this will be the starting score, and then change the alignment to center for both horizontal and vertical. Then I want to change the font type, so if I go into my theme overrides and into fonts, I can load in this pixel font that I found online. So if I drag it over, that will change the style of font. The font is a little bit small, so I go into font sizes and I'm going to set that to 50. So now the font is much bigger. Now I can position it correctly, so if I go into layout and transform, I'll set the X coordinate to 4, 5, 6 and Y to 5, just to position it to slightly to the left of this dividing line. That takes care of one score counter. Now I duplicate this for the second score counter. I'll rename that to CPU score. And it's going to be exactly the same. I just need to move that node over. So I go into its layout, transform, and I change the X coordinate to 6, 4, 8. The last node that I need to add is a timer. So I'll create another child node, set it up as a timer, and I'll rename this to ball timer. In the properties, I'm going to leave the wait time to 1 second. I'll set it to a one-shot timer, and I will let it auto start as soon as it's loaded. Now that's all of the nodes set up, so I'm going to save this scene inside of the scenes folder and then press F5 to run it. Click select current, and we should be able to see the game coming up. So everything looks good, and now we can start on the scripting to actually add in the physics and movement. I'll begin by adding a script to my main node. This is a Sprite 2D node, so the first line is automatically populated to extend it. Then I'm going to define a couple of variables. The first one is the score. I want to track the score for both the player and the CPU inside of an array. So the first index is going to be the player, the second index is the CPU, and that's what this note here explains. Then I'm going to define a constant variable, which will be the paddle speed, and I will set that to 500. That's how fast each of the two paddles will be able to move. I can save this script, and I can now add another one to the player. The player extends static body 2D, and it comes with a ready and a process function, which we'll get to shortly. For now, I just need to begin by defining a couple of variables. The first one is going to be the win height variable, which will track the height of the game window. The second variable is p height, and this records the height of the paddle. Inside of the ready function, I can assign values into both of these variables. The first one is going to be the window height. To get the window height, I first need to get the viewport rectangle using this built-in Godot function, then I get its overall size, and then I take the Y property of that size, so it's just the height. To get the paddle height, I can do the similar thing. So my p height variable is equal to my color rect node, which is a child node of my player, this node here. Then I get its size using this built-in Godot function, and I take just the Y property of that, so that gives me just the height. Now I can move on to the process function, in which I'm going to handle player input. The input I want to look for, first of all, is when we press the up key on the keyboard. So if that action is pressed, then I want to do something. And that something is that I want to move the paddle up. Moving the paddle up and down means I need to adjust its Y position. So I will decrease the Y position by that paddle speed variable, which is going to be paddle speed multiplied by delta. Delta, as this comment up here explains, is the elapsed time since the previous frame. Using this delta variable means that the game runs at the same speed regardless of your frame rate or how powerful the computer is. But here I'm getting an error that says that identifier paddle speed is not declared in the current scope. Well, the paddle speed variable is created inside of this main script, but that is a different script. That is a script that's inside of the parent node of the node that I'm trying to work on right now. So I need to access that variable by looking inside of the parent node. And to do that, I can add a prefix here, which is get_parent. This looks into the parent node and picks up any variables that are inside it, such as paddle speed. This will allow me to move the paddle up the way. I'll do the same thing for moving the paddle down using an elif statement. This time I'm checking for the action UI down, which is the down key on the keyboard. The line below is almost the same. The difference is that we're now adding rather than subtracting. I could run this code now, and if I press the up and down keys, I can move the paddle. What I need to do next is limit its movement so that it can't go off the top and bottom of the screen. I will do that inside the process function just underneath these inputs. Add a comment to say limit paddle movement to the window, and then I use the clamp function to clamp the Y position of the paddle between these two values here. Now if I run it again, I can only move as far as the edges of the screen. I can't go below the top and the bottom. And that's all that we need for this paddle, so I can save the script and I can close it down. Now I can begin working on the ball. So I'll go in here and add another script to the ball node. This extends the character body 2D node this time. We'll begin by defining a few variables, the first one being the window size, which is similar to one of the other scripts we created already. Next, I define 3 speed-related variables. The first 2 are constants. This one is our start speed. This is how fast the ball will begin every time we play the game. And then we have an acceleration, so that as the game progresses, the ball moves faster and faster. This last variable, speed, is the current speed. We will use both of the constants above to adjust our current speed. In addition to speed, we also need to know the direction, and that's what this variable here is for. This script came without a ready function, but we need one. So I'm going to add in a ready function, which will be called whenever the node enters the scene tree for the first time, which basically means as soon as this ball is created, we run this ready function. Inside of it, I'm going to assign a value to this win size variable. I'll use this built-in Godot function again, get viewport rect, and I will take its size. Another function I'm going to define is a new ball function. The purpose of this function will be to pick a position and a direction for each ball that we begin the game with. In reality, we only ever actually use a single ball. We only have one node for it, and we never delete it. But whenever I run this new ball function, I'm going to reposition it at the beginning and give it a new direction. So that's what I'll add to begin with, is a comment to explain what we're going to do. The X coordinate is not going to be randomized. That's always going to be half of the window size. So I want the ball always to start right in the middle of the game. The Y coordinate will be randomized though. I will use this rand_i range function to give me a random integer inside of a range. This range will limit the ball's Y coordinate to anywhere between 200 pixels from the top or 200 pixels from the bottom of the game screen. Then I will define the speed variable, which is just going to be the start speed. Next, I need to pick a direction. And to start with, I just want a random direction. I'm going to have to create a function for this, which is going to be random direction. So I'm going to call this function, but I get an error because it doesn't actually exist yet. I'll go down here and I'll define this new function. To pick a random direction, I'll first of all create a local variable called new direction, and this will be a vector2 variable. The X direction can only be left or right. It can only go one way or the other. So for that, I'm going to create an array which contains 1 and -1, and I will use the pick random function to just pick one of those two values. The Y direction though will have a lot more flexibility. So for this, I'm going to pick a random float from this range of -1 to +1. Now that I've assigned X and Y properties to this, I can return that new direction variable. However, because it's a vector 2D, I need to make sure that I normalize it. This will mean that no matter which direction it's facing in, the length of that vector is always the same. At this point, we've got a position and a direction for the ball. However, we're not actually handling movement. This needs to be done inside of another function, which is physics process. Just like the process function from the other scripts we created, this is called every frame and it contains a delta variable to make the game frame rate independent. Now we can move the ball using this built-in move and collide function. Inside here, I need to pass in the direction multiplied by the speed and multiplied by the delta variable. We've got most of the building blocks in for the ball. However, if I run it, still nothing happens. And that's because this new ball function never actually gets called. We want this function to be called based on this ball timer. So I can go into that node, go into the node tab at the top, and you'll see it has a signal here called timeout. I can double click that and connect it into my main node. This will add an additional function into my main script. So what I can do is add some functionality inside of this function that will only happen whenever this ball timer ticks over the 1 second wait time. And the functionality I want is to run that new ball function from my ball node. But that function is inside of a different node. So how do I get that ball here? If I click on that ball node and drag it over, I can now access the functions inside of it. So I can call new_ball. If I run the game now and wait 1 second, the ball fires out in a random direction. We still need to add some code into this ball script, but I'm going to come back to that. First, I'm going to add some functionality into the CPU node. I will create another script that will attach to that node. And like the other scripts, I'm going to begin by defining some variables. The first one is the ball position. When we play the game, we can see where the ball is and we move the paddle to intercept it. So the AI needs to do a similar thing. It needs to know where that ball is actually positioned to be able to move towards it. And that's what this ball pause variable is going to store. Next, I create a variable called distance, which will be the vertical distance between the AI paddle and the ball. Then I have a variable called moveBy, which will define how far the AI paddle should move. And lastly, a couple of variables that we're already familiar with from the other scripts. These are the window height and the paddle height. Inside my ready function, I'm going to get my window height and paddle height assigned. So this code is exactly the same as what I used in the previous script, so I'm not going to go into that again. And then we can jump over into the process function, which is where the paddle is going to move. I'll add a comment to say move the paddle towards the ball. The first thing I need to do is work out where the ball is currently positioned. The ball node is another child node, so the CPU and the ball are both child nodes of the main node. To access the variables from that, I can again just drag it over like this, and this will give me the functions as well as the variables that are inside of that ball node. So what I actually want to do is take the position of that ball and assign it into the ball pause variable. Then I need to work out how far away the ball is from the paddle. And that's what this distance variable is going to do. I'll take the current paddle position and I'll subtract the ball position from it. Now that I have these variables, I can move the paddle. So first I need to calculate the moveBy variable, which I'll do in a similar way as I did with the player paddle. I get my parent's paddle speed variable and I multiply it by delta. With that done, I can update the paddle's y coordinate using this moveBy variable. And then I remember from the other paddle, I need to restrict the movement to the top and bottom edges of the screen using this clamp function. If I run this game now, the paddle always moves to the top of the screen, regardless of which direction the ball is actually going in. So each time, whether it's going up or down, the paddle moves up the way. And that's because although the computer knows the distance to the ball, it doesn't know whether the ball is above or below the paddle. So it doesn't know which direction to move by. All it knows is the distance that it has to move by. So the position variable is always being reduced by this move by, and that's why it always goes up. But I need to know whether this distance variable is negative or positive, meaning if the ball is above or below the paddle. So how do I get the sign of this? How do I know if this is a positive or a negative value? Well, for that, I'll use a little math trick here where I will divide the distance variable by the absolute value of itself. The absolute value is always positive. So if the distance variable starts off positive, then I take a positive divided by a positive, the answer is also positive. But if the distance value is negative, then this is a negative divided by a positive, so it keeps a negative sign. This little bit here allows me to give a sign to my moveBy variable. If I run this game now, I get a divide by zero error. And that's because the ball and the paddle are at the same y coordinate, so the distance variable is 0. I'm going to add a temporary line of code here that will say if the absolute value of distance is greater than 0, then we want to run this code down here. And if I run this now, the paddle doesn't begin moving until the ball is created. As soon as it is, the paddle moves towards it. So this kind of works, but there's a little bit of an issue, which you can see here. The paddle is jittery, it's quickly moving up and down, and the reason for that is because it has a fixed speed. So every time it moves towards the ball, it overshoots, and then it has to correct itself on the next frame, overshooting again. So it gets stuck in the cycle of constantly going back and forth because it misses its target. This move by section needs to be adapted a little bit. I'm going to swap out this first line, and now I'm going to be saying that instead of just checking if this absolute distance is greater than 0, I check whether it's greater than the maximum speed that I'm able to actually move at. If it is, then this is okay. We'll move just as normal. But if it isn't, then I have an else statement here, and my move by is just the distance itself. So it's not going to be the maximum speed anymore, it's just the remaining distance that I need to move by to reach the ball. If I run it now, the result is slightly different. You can see the paddle moves much more smoothly towards the ball position, and then it stops. It doesn't keep jittering up and down. And that's us now done with the CPU script as well, so I can close that one down and go back into the ball. Because while we worked on the up and down movement, you notice that there's collision here that isn't really working. We're detecting a collision, but then there's no bounce back. Back inside of the ball script, where we have this move and collide function, I can actually return a value from it, which is going to be the collision. So whenever it detects the collision, it returns an object from that. Using the collision, I can then extract a collider. I'll create a variable for that to store the value when we get it. First, I need to check if a collision has actually been detected. If it has, then I can take the collider object from that collision using the built-in getCollider function. And then I can check what it's collided with. The first check is whether I've hit one of the paddles, and that's done by comparing the collider to one of these nodes. To get the node over here, you can either type it out manually, or just like I did previously, you can drag over the node that you're interested in, and it will add in the node name like this for you. If the ball has hit one of the paddles, then I need to do two things. The first thing is I need to increase the speed by the acceleration value. The second thing is that I need to bounce off of the paddle. And for that, we have a bounce function built into Godot, which will take the current vector as well as the collision, and it will work out the new direction that we need to move in once we bounce off the paddle. And that takes care of the ball hitting the paddles. So the other option is that if it hits one of the walls. We add an else statement down here, and I add the same code from above to bounce off of the wall. If I run the game now, I should be able to bounce these balls back and forth. So you can see it's bouncing correctly from the top, the bottom, as well as both of the paddles. And each time we hit the ball back, it actually speeds up a little bit based on the acceleration. So everything there works pretty well. However, the way the ball bounces from the paddles is a little bit predictable. In the actual Pong game, the angle of return depends on which part of the paddle was hit by the ball. This means it doesn't matter what angle the ball came in at. If the ball hits the paddle right in the middle, then it bounces off perpendicularly, but a collision further from the center bounces back with a greater angle. So I'm going to create a new function that will take care of this new direction calculation. I'll define a function called new direction, which will take the collider as an argument. Then I need to work out how far along the paddle the ball hit. For that, I need to know the position of the ball, and I also need to know the position of the paddle. I then calculate the distance between the two and create a local variable to store this new direction inside of. The first part when we hit the paddle is to flip the x coordinate, because now if it was going left, it goes right, and if it was going right, it goes left. It just bounces off the paddle completely. And that can be done with this little block of code. It says if the direction x property is moving to the right, i.e. is greater than 0, then we just set it to -1. But if it's moving to the left, then we set it to +1. The y variable is a little bit more tricky. We take the distance variable, which is how far the ball center is from the paddle center, and then we divide it by the height of the paddle. This gives us a ratio. The greater this distance, i.e. the further the ball is from the center, the greater this value is going to be. I need to then define what the maximum value could be, and that's going to be an additional constant right at the top. This is going to be the max y vector that we can bounce off at, and I'm going to set this to 0.6. I can then use this as the final value in this calculation. So once we get this ratio, we multiply it by the max y vector. Once we have the new direction x and y properties, we have to normalize that vector and return it back from the function. To apply this change, we go into this section here where we check for collision with one of the two paddles, and now instead of just directly bouncing off, we call that new direction function. And if I was to test this out now, Every time the ball hits the CPU paddle, it's kind of bouncing off in the middle because the CPU panel matches up nicely. But if I was to hit one of the edges of my paddle, you can see that it bounces off at an angle. Same with the top and the bottom. And that makes the game a lot more unpredictable. And that's the ball script complete as well. So we can close this one down, and the only thing actually remaining is to take care of the scoring. Because we've got all of the collision, the ball bounces off correctly from the top, the bottom, as well as the paddles. But when the ball goes off the left and right edges, right now nothing happens. There was a reason why I set these up as Area 2D nodes. If we select on one of them and go into the node here, we can see that it has a number of different signals. The one that I'm interested in is body entered. What I can do here is link the signal into my main node, just like I did previously with the ball timer. And this creates a new function for me. I can do the same with my score right node as well, and link the body entered signal into here. And now I can populate these functions. This first one means that the ball has gone through the left hand side, and that means that the CPU is the one that scored. So I increase the score for that player. If I go back to this variable up here, I store the score as an array. The first value is the player score, the second value is the computer score. So that's why I'm increasing the second value by 1. That will increase the variable, but I also want to update this label up here. I can access it by going into my heads-up display and dragging over the CPU score node. I can then go into its text property and set it to the string of this score value. Once the score is updated, I also want to restart that ball timer so that we get another ball generated. And now I can do the same for the other function. This one is going to record the score for the player, so it's going to be the first index at index 0. Additionally, it's no longer the CPU score label, it's now the player score label. So if I test this out, I can try and get a couple of points. So if I miss the first one, now the CPU has scored. It's actually very difficult to beat the AI on this, so I'm very unlikely to score anything, but you can see that the scoring is working correctly, and once the score is done, we generate a new ball at a random direction. And now you have a fully functioning Pong game complete with some AI. If you want to take this further, then you could try adding sound effects or replacing the CPU with a second controllable player. I hope you found this video useful, and I'll see you in the next one.